Okay. The figure shows a block of 5 kilograms resting on a rough surface. The coefficient of static and kinetic friction between the surface and the block are respectively 0.5 and 0.4. If the angle theta equals 30 degrees, what is the minimum magnitude of P in newtons to cause the block to move? And we have this force vector P. Now, because it's pointing at an angle, we have to break that down into x and y components. So there's a component right here, and there's a component right here. Now, once we do that, we can understand what's causing this block to move to the right and what's restricting it. Making a free body diagram, we have the force vector px pushing it to the right, and then we have keeping it down, which is going to be the weight, and the force in the py direction, because py is going downward, right? Now, because these forces are pointing downward, it has a normal force because it's on a surface right here. Now, the first thing we're going to do is find our normal. Our normal force N equals our weight, so it's going to be the mass times gravity. We're going to add that to our P sine of 30 degrees because sine is opposite over hypotenuse, and that's going to be that line right there. So now that we have that, we can go ahead and solve for friction force. So in order to move it, we have to beat our static friction. So it's going to be F sub S. So our static friction is going to be equal to the normal force times mu sub S, and that's going to be equal to G plus P sine of 30 degrees, and we're going to multiply all of that by the coefficient of static friction, which is going to be 0.5. Just to make life easy, I'm just going to make it 1/2, and there we have our static friction. Now, in order for the block to move to the right, where Px, which is moving it to the right, has to be greater than our static friction. So our Px is going to be equal to P cosine of 30 degrees, and that's because P in the x direction is going to be right here, because it's going to be something like that. And to get this line, we can do cosine, which is adjacent, which is going to be this line over hypotenuse. We can use cosine. From there, we can go ahead and rearrange the equation to where this is greater than this, because that's what's causing it to move. So P cosine of 30 degrees is greater than mg plus P sine of 30 degrees, and we're going to multiply that by 1/2. Now from here, we're going to go ahead and try for the P. So we can go ahead and we can go ahead and get rid of the 1/2 and move it over. We have 2 P cosine of 30 degrees, which is greater than mg plus P sine of 30 degrees. Now we have to get this P to the other side because we want to isolate it. So we have 2 P cosine of 30 degrees, and we're going to go ahead and subtract P sine of 30 degrees, which is greater than mg. Okay, now from here, we can go ahead and take out the P. So we have 2 cosine 30 degrees minus P sine of 30 degrees. We have this greater than mg. Oh, we can go ahead and isolate our p, so divide this by this. So we have is greater than, divide that by 2 cosine 30 degrees. And we're going to go ahead and subtract that by sine 30 degrees. And this is going to be the equivalent of p is greater than our mass, which is 5 kilograms times 9.8. We're going to divide that by 2 cosine of 30 degrees minus sine of 30 degrees. Now, when we plug this into our calculator, it needs to be greater than 39.77 newtons.